So I'll first read out the question. So that the conic represented by the equation given below is an ellipse. Also finds its. So the given equation, we are given the equation, and we have to first find out if the given equation is an ellipse, will represent an ellipse, and after that we have to find out the center of an ellipse. Equation refer to the center, equation of axis and length of axis, eccentricity, length of latus rectum, foci, and directrices. So the things we have to find I have written on the right side, and the equation is given here. So I'll first let this equation as equation 1, and we know the general equation of second degree, that is ax square plus 2h xy plus by square plus 2gx plus 2fy plus c equals to 0. So this is the general equation of second degree, and I'm comparing equation 1 with this general equation. So we can write a equals 5, h equals to 3, b equals to 5, and g equals to 6, f equals to 2, and c equals to -4. So we have to find out whether this equation represent an ellipse. So for that we have two conditions. The conditions are if its determinant is not equals to 0, and ab minus h square is greater than 0. If these both conditions are fulfilled, then this equation will represent an ellipse. So moving on to the first condition, we have to find out the determinant, that is writing in the matrix form. It is 5. I'll first write the formula, that is a b c h h g g f and f. So we are finding the determinant of a 3 by 3 matrix, which is let's see, 5. Now I'll write 5, then -4, then we have 3, here also 3, then 6, and again 6, we have 2 and 2. If we find the determinant, then it will be equal to -192, which is not equal to 0. So the first condition is fulfilled. Now moving on to the second condition, that is 1 ab minus h square. So on putting the value, we will get 5 into 5, that is 25. 25 minus 3 square, that is 9, which is equals to 16, which is definitely greater than 0. So we can conclude that both the conditions are fulfilled. That means equation 1 will represent an ellipse. Now further moving on to the things we have to find out, that is on the right side. So moving on to the second part, that is the things we have to find out for an ellipse. So first of all, we have to find the center, and to find the center, the equation, we have to first partially differentiate equation 1 with respect to x, and then we have to partially differentiate equation 1 with respect to y, so that we can get another equation 2 and equation 3. So on further solving equation 2 and equation 3, we will get the center. So I am first partially differentiating equation 1 with respect to x, then we will get 10x plus 6y plus 0 plus 12 plus 0 minus 0 equals to 0. So we'll get 5x plus 3y plus 6 equals to 0. This is the equation 2. We have partially differentiated equation 1 with respect to y, where with respect to x, where y acts as a constant. Now again, differentiating equation 1 with respect to y partially, we'll get so I'm not writing the 0 now, 6x plus 10y plus 4 equals to 0. So this is our on the further solving, 3x plus 5y plus 2 equals to 0. So this is our equation 3. Now on solving equation 2 and equation 3, we will get the center. So we can simply use the calculator, that will be much easier. So the center is minus 3 come by 2 and 1 by 2, which we can write as alpha comma beta. That will be used further. So alpha is equals to minus 3 by 2 and beta is equals to 1 by 2. Now I think I should write these things, which might be helpful. Is definitely helpful. Minus 3 by 2 and beta is equals to 1 by 2. So this is our center. Now to find out the equation referred to the center, we are shifting the origin. We are shifting the origin to minus 3 by 2 and 1 by 2, which we found earlier. So x is equals to x minus 3 by 2 and y is equals to capital Y plus 1 by 2. Therefore x will be x plus 3 by 2 and y will be y minus 1 by 2. So I'm supposing this as equation 2, which I think I should write here. X is x plus 3 by 2 and y is y minus 1 by 2. So and we shifted the origin. Similarly, the new equation will be ax square plus 2hxy plus by square is equals to determinant by h square minus ab. So we previously found out the value of a, b, h, and now we have to substitute the value of a, b, and h. I think I rubbed that part, so let's do that manually. A will be 5x square plus 2 into h will be 3 times xy plus b is also 5 by square. With determinant we found out minus 192 earlier. H is 3, which is 3 3 is a 9, minus ab is 25. On solving this, we will get 5x square plus 6xy plus 5y square is equals to 12. Now what we have to do, we have to make the right hand part as 1. For that we have to divide on both sides by 12, then 6 by 12 xy plus 5 by 12 y square is equals to 1. Now on further solving, 5 by 12 x square plus 1 by 2 xy plus 5 by 12 y square is equals to 1. So this is equation, I am supposing it as equation 3, and this is the equation referred to the center. So we have solved the second part 2. Now moving on to the third question, that is we have to find out the equation of axis and length of the axis. So going on, so I'm not rubbing the third question, equation 3, which is which we required further. First of all, I am going to find out the length of axis, and then using that I can find out the equation of axis. So for now we have to compare equation 3. Now I am comparing equation 3 with ax square plus 2xy plus xy plus by square is equals to 1. Since I am comparing this equation, this is standard equation, with this equation which was obtained earlier, we'll get a is equals to 5 by 12, h is equals to 1 by 4, and b is equals to 5 by 12. Now using these things we can find out the length of axis, that is major axis and minor axis. Now we don't need this, so I am rubbing this. Now we have the relation 1 by r4 minus 1 by r square a plus b plus ab minus h square is equals to 0. Now substituting these values a, b and h here, we can find out the value of this r. and these are after solving this equation we'll find out two values of r, which one of that will be the length of semi major axis, and another will be the length of semi major axis, semi minor axis. So I'm doing that. 1 by r square, this is a plus b, that is 5 by 12 plus 5 by 12 plus AB, I'm simply writing it as 25 by 144 minus as is, that is 1 by 16 equals to 0. So I'm further solving, it will be 1 by r square, that is 10 by 12 can be written as 5 by 6, I guess. Yeah, 5 by 10 by 12, 5 to the 6, yeah, plus it will be 16 9s, that will be 5 minus 16, I guess 1 by 9 is equals to 0. So now you can see that if we suppose 1 by r square as x, then we'll get that this will be x square, this term will be x, and here it is a constant, then it will be changed into the quadratic form. It's still in the quadratic form, but that will be much easier to solve. So on doing that, simply using the calculator we can find out the value of 1 by r square, which is obtained as 2 by 3 and 1 by 6. Now the value of 1 by r will be plus minus root 3 by 2 and plus minus 1 by root 6. But ignoring the negative values, we'll get the value of 1 by r as root 3 by 2 and root under and 1 by root 6. Let me check once. I have little mistaken here. This is 2 by 3. This is 2 by 3. Root under 2 by 3. This is root under 2 by 3. Now since we got two values of r, here we can write r is equals to root 3 by 2 and root under 6. Since we got two values of r, one of them will be the length of semi major axis and the other will be the length of semi minor axis, and we are supposing the bigger length as semi minor axis and smaller as semi major axis. So I am writing r1 for semi major axis, which is root 6, and r2 for semi minor axis, that is root under 3 by 2. I'm writing it here, it will be used further, that is root 6, and r2 will be root under 3 by 2. So I'm rubbing this part. So we finally got the length of axis. So these I forgot to write the value of a, that is capital A is equals to B is equals to 5 by 12, and I think and H was 1 by 2. Oh, sorry, 1 by 4. I'm not correct. Yeah. So what do we have to find out? So we find out the length of semi major and semi minor axis. If we multiply it by 2, then it will be the length of axis, that is major and minor axis. Now I'm going to find out the equation of major and minor axis. So for major axis, we have the equation 1 minus r1 square times x plus h times of y is equals to 0. Now substituting the value of a, r1 and y, will get 5 by 12 times 1 by r1, that is r1 is root 6, so we can write 1 by 6 times x plus h is 1 by 4 times y is equals to 0. And further solving we'll get 3 by 12x plus y by 4 is equals to 0. 3 4 12, this will be x plus y is equals to 0. Now on substituting the value of x and y which we found earlier, we can write x plus 3 by 2 plus y minus 1 by 2 is equals to 0, which is x plus y plus 1 is equals to 0. So this is the equation of major axis. Similarly, we can find out the equation of minor axis as well. So I'm taking it as equation 4. So I'm rubbing this all. Similarly, for minor axis, we have the same equation where we have to replace r1 by r2, a minus 1 by r2 square times x plus hy is equals to 0. Now we can write minus 1 by the value of r2 is root under 3 by 2, and if you write it here, it will be 3 by 2 times x plus 1 by 4 times of y is equals to 0. Let it be here, x plus y plus 1 is equals to 0. This is our equation 4. It will be used further. So this is 5 by 12 times 2 by 3 times of x plus y by 4 is equals to 0. Now this is minus 3 by 12 times of x plus y by 4 is equals to 0. This is minus x plus y is equals to 0. Now substituting the value of x and y, we will get minus x minus 3 by 2 plus y minus 1 by 2 is equals to 0. This will be minus x plus y minus 2 is equals to 0. This will be x minus y plus 2 is equals to 0. So this is the equation of minor axis. Now we have successfully found out the value, the value of that is length of axis, and then we found out the equation of axis. Now moving on to the next part, that is we have to find out the eccentricity of ellipse. So for that we have the relation, that is r2 square is equals to r1 square 1 minus e square. This is simply read as earlier we might have read b square equal to a square 1 minus e square, where b represents the length of minor axis, semi minor axis, and a length of semi major axis. So both have the same thing. Now putting the value of r2 and r1, we can find out the value of e, which is the eccentricity. Now r2 is equals to 3 by 2 and r1 is simply 6. This is 1 minus e square, that is 3 to 6. We'll get 1 by 4 equals to 1 minus e square. So e square will be equal to 1 minus 1 by 4. So e square will be equal to 3 by 4. So e is root under 3 by 2. So we found out the value of eccentricity. Now it will be used further, so I am writing it here, root under 3 by 2. Now moving on to the next part, we have to find out the length of latus rectum. Length of latus rectum, this is twice r2 square by r1, that is 2 into, that is 3 by 2 by r1. r1 is root under 6, that is 2 to cut, 3 by root 6, which is so we can write root 3 into root 3 by root 3 into root 2. This is root 3 by 2. So we found out the length of latus rectum, and going on to the next part, we have to find out the foci and the directrices. I mean, this should be the equation. This should be the equation of directrices. Yeah. Now we have to find out the coordinates of foci. So for that we have the relation foci alpha plus minus e r1 cos theta and beta plus minus e r1 sin theta. So this is the relation for the foci, and here we can see we have found out the value of alpha, eccentricity, semi major axis, beta, eccentricity, same major axis. So we are given everything here except the value of cos theta and the value of sin theta. So for that, to find the foci, we have to find out the value of cos theta and the sin theta. So for that, I'm using equation 1 from equation 4. From equation 4 we have x plus y plus 1 is equals to 0. Slope of this equation will give us the value of tangent. Slope of 4 is equals to tan theta will be equals to minus 1 by 1. So tan theta is minus 1, that is theta is equals to 135 degree. Similarly we can find out now, since we know the value of theta, we can find out the value of sin theta and cos theta. So sin theta is equals to 1 by root 2 and cos theta will be equals to minus 1 by root 2. Now we know the value of sin theta and cos theta, so we can simply find out the value of foci, that is coordinate of foci. So I'm substituting the values here, write it clearly. This is cos theta, this was sin theta. Now on substituting the value, we'll get alpha and beta came from the center, so that is minus 3 by 2 plus minus e was the eccentricity. I think I rubbed that. It was root 3 by 2, I guess. Yeah, it was root 3 by 2 into r1. R1 is root 6 into cos theta was minus 1 by root 2, comma beta is 1 by 2 plus minus root 3 by 2 into it was root under 3, it was whole, I guess. It was whole. This was whole into sin theta is 1 by root 2. So on further solving it will be 2 3. This will be, you can write it, this minus will make it minus plus, so this will be 3 by root 2. Yeah. So this is our x coordinate, and the other one is this will be 1 by 2 plus minus, this is I didn't write the value of r1, I forgot the value of r1. So r1 is root 6, so it will be root 3, this is also 3 by 2, 3 by root 2. Yeah. So these are the equation of these are the coordinates of our foci. This is the x coordinate, similarly this is the y coordinate. So we found out the coordinate of foci. Now moving on to the last part, that is we have to find out the equation of directrix, and for that we have equation of directrices, that is x minus alpha This is x minus alpha cos theta plus y minus beta sin theta. This will be equal to plus minus r1 by e. Now substituting the values of alpha, cos theta, beta, sin theta, r1, eccentricity, we can find out the equation of directrices, which will be two equations representing two directrices. So substituting the value, we can get x minus alpha is 3 by 2, so I am writing plus 3 by 2. Cos theta is minus 1 by root 2 plus this is y minus 1 by 2, this is 1 by root 2 equals to plus minus r1 is root 6 by e was root under 3 by 2. So this is now minus x by root 2 plus, no, this is minus again, minus 3 by 2 root 2 plus y by root 2 minus 1 by 2 root 2 will be equal to plus minus, now this is root 2, and root 2 into root 2, this will be 2. So this is now taking the LCM, we'll get minus 2x minus 3 plus 2y minus 1 will be equal to plus minus 4 root 2. Yeah, so on further solving, it will be minus 2x plus 2y minus 4 is equals to plus minus 4 root 2. Further it will be minus x plus y minus 2 is equal to plus minus 2 root 2. Further it will be y minus x is equals to 2 plus minus 2 root 2. So this is the equation of our directrices. Now taking plus and minus sign 2 times, we can get the equation of directrices. So this ends our solution. Thank you.